Hello and welcome back to class number 9 of Immersive VR Compositing with Nuke. And I am your professor, Daniel Smith, and welcome. This week we are going to be taking our scene that we put together last week inside of Nuke, and we're going to be rendering it out for VR. And we're going to be setting up our 360-degree cameras. Not only are they 360s, but they're also going to be producing a stereo render inside of VR, because we have our stereoscopic screen, which has a stereo texture. And if we look back at our file, we can see that we have the little V, the multi-view inside of there. But we also have a stereo environment or a 3D environment. So we're going to be creating two lat-long equatorial panoramic images that are going to be mapped to VR today. And we're going to be doing a bunch of little things to tweak our environment. All right, so the first thing I want you to notice is that in today's downloads, I've given you a new folder called Nuke Assets. Now, the Nuke Assets, all in here, from the motion base all the way through all these different objects, has been updated. And what I want you to do is to replace that folder with the new objects and keep the folder name the same. That way it will just automatically load. All the file names are the same. They'll just load in to your new stuff. Now, the reason I did this is because remember last week I had some issues where certain objects such as the ground here, let's go over to the ground, I had to use a diffuse shader to kind of make this ground equal with that ground. And otherwise it rendered like this. And I figured out what the issue was after I finished a class. And so what happens is and I'm going to go into what fixed it. If we jump over into Maya and let's say we bring in the grass over there. So let's see, where is it? Bridge grass. There it is, bridge earth. So I'm going to bring that object in. And we can see that even in Maya, the object is black on the top and underneath it's gray. And that's where I had an aha moment, and I realized that the surface normals are broken and inverted. So if we go to mesh component display and I display the normals, and I'm going to give them a much larger size, I can see the surface normals are all pointing downward. So I went through each object and unlocked the normals and reversed the normals and gave them a new smoothing angle and then returned them. And now with this saved back out, it loads correctly back into Nuke. So let's jump back over to Nuke right now. So you can see back in Nuke, this is the file from last week. And if I replace those objects and reload the file, what's going to happen is you get this right here. So what you want to do is go through your file and just clean it up. And like things like this diffuse, we don't really need that anymore. So I can just delete that and I can connect that to the color correct directly. And you can see now that grass is equal and much better. And you can tweak those little places that we put in here, tweak them, and that way the lighting is going to respond better. So I included an updated version of this file with today's downloads, and that's in the Nuke 9 class. The file that I want you to open up is called class09 start, and we're going to be using this one right here. And this has all the different things slightly modified. I got rid of a lot of those shader fixes, but I kept some of them because of the way they work. But the big other update from last week to this week is the motion platform. Now, the reason I have the motion platform updating is because I noticed that the UVs got corrupted on the Alembic file that I previously gave you. So I have a new Alembic file that is got better UVs, and there's also a texture in there for us to use. So I'm going to jump over to Maya, and we're going to talk a little bit about that. And now we're back in Maya, so let's create a new scene. And there's a new file inside of our class 9 called seats. And this is our new version of the top of the base. And the base, the ride platform, first of all, it's in sub-D mode, and we can't really see sub-Ds in Nuke yet. So you have to set that to subdivision 1, and then we have to set this to smooth mesh. And I usually leave it at 1 subdivision because it's pretty heavy as it is, but that gives us a good resemblance of what we need with good interactivity and speed. Now, the other thing we need to do is to attach any old shader or texture to it. And in class 9, there's this silly looking map that goes on there. And you can see now our seats aren't all the same color. We've actually got like a nice little diamond plate bottom and a wonderful logo on the front of our ride vehicle. We never see it in the actual ride because we will be looking from this direction. How do we get this thing onto our ride base? So I'm going to save this out. I sent out the motion base already. You can see that this is the old version right here. And what we really want to do here is we want to, well, not delete it. We don't want to get rid of it. But what we do want to do is we want to open up our area right here, and we want to move it. Now the shot cam is not really needed anymore because we already got our cameras into Nuke. But if we want to preserve it, what we can do is we can unparent it or move it to a different location. But what we need to do is we need to import the new file, seats, import that. And we want to bring in our new seats. And we want to parent them in the same relationship as before, which is right about there. So that way it's in the same structure. And then go to the channel box and we'll zero out these transformations. And probably the scale. Nope. Looks like the scale transformations are still valid. So 1, 2, 5. There we go. So now we have it in the exact same place as it was before. And this way now we can export our a new version of our Alembic. And what we want to do is we want to basically get rid of the old seats, but we have to move our parenting relationship of the cameras to the new seats. So that way we can just delete those old seats. There we go. So now we have our new seats on the motion base with the same animation, and then we can select the whole group and we can generate a new Alembic cache and export that out. Now I already went ahead and did this, and it's in the Nuke assets folder today. Let's go back to Nuke and let's bring in our new Alembic cache. So we're going to do a regeo and bring it in yet again. Lots of updating. So here we go with Nuke 9 or class 9 assets, create all in one, and give it a few moments and it will update. Okay, so let's we already have our cameras. So we already got our stereo cameras down below. They haven't changed. So I'm going to just delete all that, and I just want the new motion base right here. So we're going to bring this down here, and let's view that for right now and hit F. There we go. And we also have our new piece of texture. So we can read that in, and we can read that straight in. That was also in the Nuke assets folder, and it is called, there it is, color1001.png. Hit open and connect the image to there. Now you can see that we've got something hideous right here, is because the UVs for the motion platform are not exactly set up well either. But I didn't really feel it necessary to fix those because, well, we never see it. So we've got that on the platform. So what I'm going to do is I'm going to actually copy, paste the motionbase.abc, and we're going to split the two. So on this one right here, open it up and open the scene graph. And what we can do is we can actually hide the other geometry that's in here that doesn't apply to the seats. So the platform geo, we can uncheck this button and it all goes away. All right, so we want to hide the base, and then there's the male pistons right here. We want to hide those as well. There we go. So now we just have the seat. Now we're going to do the opposite for this one. So let's close that properties bin, and we're now looking at this one. And what we're going to do is we're going to hide, open up the platform, motion base seats right there. There we go. So now we're going to combine those two together. So let's take a scene and connect the two together like that. And there we go. So now we have the best of both worlds. But I'm going to also add some shaders over here. So we're going to add, over here, we're going to add something like a Phong shader to the base. And we'll make it basically a black object. And then over here, we're going to add a basic material shader to that. And what we're going to do is we're going to zoom in and we're going to switch the map to be its diffuse component map. So map D. Let's bring that up. And let's take a look at what we have rendering. Well, actually, you know what? We can't quite see it yet, so we'll come back to that shader in a little bit. Well, we could see a little bit inside of here, and we can see that the spec is a little high. So it's not quite rendered, but we'll modify a couple things real quick. We're going to lower the diffuse down and spec down. There we go. That's much better. And we'll make the shininess between 8 and 20. There, that's a lot better. That feels much, much better. And this Phong over here, oh my goodness. Let's reduce this down a lot too. But guess we never do see it, so I guess that doesn't really matter. Okay, so we now have our environment, and we can see that the new ride vehicle is riding along nicely through the light and everything. So I'm going to save this. Awesome. All right, so now it's time to create our 360-degree cameras. We need to make our own camera system that's going to render an equatorial panorama out of Nuke. And an equatorial panorama is a lot like the original image that we had couple classes ago. I think it was what, class 4, and we have our sky dome. There it is. So our sky dome, you remember this? It was an equatorial panoramic image. It was stitched out of a 360-degree camera rig, and the resolution is always a 2-to-1 aspect ratio, or a lat-long image, latitude, longitude. This wraps perfectly into a sphere. Now, one of the things about Nuke is that we have the ability to create a perfect VR camera system. Let me pop up this little thing over here and show the camera rigs for VR. And they're all over the place. I mean, this GoPro rig is really awesome, the Freedom rig. And it allows you to basically put a little box in and, shoot in all sorts of different directions. Now, the whole reason, why do some of these have a gazillion cameras? Some have a few cameras. The GoPro has 6 cameras. And this one with the red has a ton more. It's all about coverage. And sometimes it's about stereo too. So you'll see stereo pairs in some of these rigs so they can get stereo views out of each way, but it also is about coverage. You need about 20% to 30% of the image to be able to successfully stitch one image into the next image. And that's one of the kind of problems with doing VR right now is the fewer, the more lenses you have, the more chances that you'll have strange parallax within the image that has to be fixed. And one of the big advantages that we have in doing this inside of Nuke is all of these cameras have different optical centers, because the optical center is usually at the lens, right where it bends the light and then puts it onto the film back or the sensor. And all of these rigs don't have a true center point. All their centers are like out several inches from the actual movement center. So you get these strange artifacts, which then will have to be cleaned up. And that's been addressed in some of the other FX PhD VR courses, where you'll see that as one part of the image moves from one image seam area to the next, there's these aberrations that have to be cleaned up and patched and fixed. So because we're operating in digital inside of Nuke, we have a tremendous advantage to be able to create cameras that can exist physically in the exact same spot. So I'm going to be able to create a rig in which cameras point in all directions to film this in 360, but have the same optical center. And that's the key. That's the important thing here. So we're going to start off by creating a camera. So here we go. There's our first camera. Yay! And this one's going to be our up camera. So I'm going to say cam up, because we're going to make a cubic image. And this particular camera is going to need to be placed inside of our environment, but I want it to be rotated 90 degrees pointing straight up, and I'm going to rotate it 180 degrees around. All right, and this is so it gets what is going to be straight up. Okay, but now we're going to copy, we're going to paste, and we're going to create another camera. And we're going to call this cam down. All right, so we're going to do the exact same thing over here, except we're going to go -90. But you see right now we have two cameras, both the same image center, same optical center, one pointing up, one pointing down. The other part of this equation is we are rotating everything at 90 degrees. So in order to properly cover, our field of view needs to be equal to that. So what we're going to do is we're going to go to our projection, and each one of these cameras is also going to have a 45-degree focal length, which is half of 90. Because we're going to be rotating each camera at 90-degree increments. So what we need to have is not only 40 or 90-degree increments of rotation, but we need a focal length that's half that rotation, and we need a horizontal aperture and a vertical aperture of both 90 degrees in both directions. 90 and 90. All right. So this is essentially is now filming a perfect square up and a perfect square down. All right. And we're going to do the same thing with the other axes. So let's just copy this so we don't have to redo the field of view and the focal length. And we're going to call this one cam. We're going to go right, and we're going to go left. Okay. So camera right, camera left. Let's close these other windows here. And for our camera right, we need to, well, it doesn't need to be pointed up or down, but it does need to be pointed to the right. So let's change this value right here. Well, let's just start with 0. And we're going to rotate it to the right. Although, yeah, I'm looking down the wrong axis, so this should be negative 90 to the right. There we go. So you see that camera is now looking to the right. And what I also want you to see is notice that the field of view of the right camera now fits almost like a puzzle piece. Let's move it. See how it fits the cone of the camera looking up and the camera looking down. It fits like a puzzle perfectly inside of that, filling the exact space. So now let's take our camera left, and this one's going to be 90 degrees to the other way. So now it's camera left, camera right, camera left, camera right, camera left, camera right. All right. There we go. And now we need 2 more cameras because, 4 wasn't enough. So let's just copy and paste both of those. And we're going to do cam front back. Or, you know what, cam on the Z. So we'll do Z positive, Z negative. That's it, So cam Z positive, should probably be just zeroed out. Yeah, 0, 0, 0, 0. So now it's pointing down the Z axis in the positive. We could also call that front, the front cam. And then cam Z negative should be, 180. There we go. So now we've got it set to 180 degrees the other way. So now we've got all 6 sides, 1, 2, 3, 4, 5, 6 cameras pointed in all directions. We have a 360-degree coverage of a complete cube. Sweet. So now what we need to do is we need to hook these all up into a system that's going to allow us to render all of these images. So we've got all these different cameras, and we basically want to render our scene using this camera. So let's bring our data over here, and we're going to just put another scene node down to allow it to aggregate it into our new setup. Let's move this over. And I want to have all of these cameras in this scene node. And let's trying to just organize all this stuff so it's out of the way. Get all this stuff kind of in there. Okay. So let's make sure that we have all of these different cameras. We have left, down, right, missing one. Okay. Bummer. Okay, there we go. So for now, we won't put these on top of one another. It's going to get a little messy, but it'll be okay. So we should have 1, 2, 3, 4, 5, 6. Got 2 too many. There, that one's coming in twice. Okay, so I've got 6 and 6. Okay, great. So now what we need to do is we need to set up scanline renders, because what we're going to do here is render each one of these cameras' views from a different point of view. So I'm going to set up a cam right there. Put that camera with the objects that are coming from this scene. And let's take a look at what that will look like. Okay. So right now that's rendering straight up a wall. Okay. Let's gain up the image. Yeah, and it looks like we're outside the wall. Okay. So what we need to do is we need to have a central way of controlling all of our cameras, and that's going to be with an axis node. So let's create an axis node up here and connect all of our cams to this one axis. This will allow us not only to move our camera around, but it'll also allow us to pipe in the animation data when this is all done. So I'm going to move this 100 units in. All right. And let's take a look at what we have. All right, it looks like we're inside of the grass over here. So we're gonna bring that back out a little bit there. So right now, this is just for setup purposes. We're gonna zero this data out in a little bit, and let's just, because we need an environment to be able to double check all our math. Okay, so that looks good. So let's go back to our 2D and see what renders out. Okay, so now this is looking good. We're actually staring at the ceiling here, which makes sense. All right, so Let's give that just a little gamma boost so we can see it. Now, it's going to become incredibly inefficient to be rendering 4K renders for 6 cameras times 2, so 12 cameras at 4K for every single camera. And also, the resolution's wrong, the aspect ratio. Remember, these cameras have 90-degree field of views and 45-degree focal lengths. So they're square. So we should be rendering square images. So the easiest way to do this is to create a constant. And what we're going to do is we're going to pull down to say a 2K square and feed it into the scanline render. So now we've got an actual perfect square image here. So let's go ahead and copy, paste, 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 paste. Okay, so this way we have a scanline for each and every camera. And we'll connect the same background to that one constant. So if we want to change the resolution later, we just change the resolution of the constant. And the camera goes up to each camera. And the objects go to that scene. There we go. So let's lower these down a little bit so we can read what they say. Okay. So there's our up. This should be our floor. This should be to the right, to the left, to the front, and to the back. Awesome. So now we need to put this into our panoramic image. So the way that we do this is through a special transform called the spherical transform. And this will allow us to construct a lat-long image or an equatorial panorama from these 6 orthogonal skybox images. We just have to pay close attention to where everything is coming from. So right here, the first input is negative Z. So we have camera Z neg, and we're going to connect that right over there. And now the next input, well, it doesn't want any more inputs. You know why? It's because the input type is set to mirror ball. That's not what we're inputting. We're going to input a cube. So now it's got more inputs. And we're going to output a lat-long map. So now we've got Z positive. There we go. And if I hit view on the spherical transform, you're going to be able to see some of the images as they update. And let's get a little bit more screen real estate here. Right there. So you can see that Z negative is this one right here, where we can see the ride vehicle, and our forward image is right there. And then X negative would be looking down at the floor. I'm sorry, X is right and left. So let's see. That might be left, that might be right. But we'll be able to figure it out. Yeah, see, that's the wrong one, because we can see the log and the road don't blend together quite right. So let's switch it over there. Perfect. See how those are blending perfectly together? And that's because of the field of view. And now we got to do our floor and our ceiling. Right here, that's Y negative. So that should be the floor. There we go. And Y positive should be camera up. Perfect. Awesome. Okay, so now what we need to do is our output is Ultra 4K, but that's an incorrect output for lat long. Now, our lat long should have a 2:1 aspect ratio. So what we want to do is we want to create a new one, but we're going to call this new one VR output. And we're going to use the 3840 width, but this is the wrong height for a 2:1 aspect because that's a 16:9 aspect. So we can do it by 3840 and we can put a divide by 2 and get 1920. And now we have a 2:1 aspect ratio. Click OK. And now that is the correct output. All right. Now, another way that we can optimize our rendering times and make sure that we're not rendering too many pixels is by going to the constant and taking 3840, and it's basically we've got the width should be 3840 should be the same size as 4 tiles because we have 4 cameras that create the width, you know, front, back, left, right. So if we divide this by 4, we should get 960. And that's the resolution we should be rendering for all our tiles is 960 by 960. So VR square. All right. And that's going to optimize our rendering times because then we won't be rendering larger files than what we need for this size of VR. Now, the reason that I'm sticking with 3840 for the VR is that, and we're going to get into a lot more detail on this one next week, is the different platforms for viewing content, at least equatorial panoramic images, let alone stereo images, is pretty much limited to 4K right now online and across mobile devices. If you go higher resolution than that, you're going to get into a lot of problems with frame playback issues and just bandwidth in general. So for our purposes, we're going to stick with a 4K width of 3840. All right, cool. So we have our camera rig set up right now, and we can prototype, we can test to make sure that this is working by creating a sphere and mapping the output image onto a sphere and then taking a look at it in the 3D space of Nuke. So here you can see the image is mapped onto the sphere. We're going to turn off the grid if it ever updates. There we go. And if we go into the sphere, there we go, and then just simply click and rotate around, we can examine for image seams or any sort of blending errors, and it looks pretty darn good. Now, it looks fairly low res right now, and you can see we are in the inside of sphere, so it's kind of inside out. That's why the text is backwards. But for the most part, it's working very, very nicely. So awesome. Good, 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 good. So we know that everything is working correctly. So we can throw that to the side. Now, another thing that I want to do here, though, is my spherical transform currently right now. Well, actually, you know what? It's kind of hard to tell right now, but one thing is I don't like, we have to put our camera move on here, but I don't like that our screen where our main event is happening is on the edges I'd like to keep it somewhere in the middle, but we really have to see it from the point of view of the camera. So I'm going to go ahead and do the next part, which is we're going to clone this, make it into another eye, and get the camera move on there. What we need to do here is we need to take our axis node and we need to set all its translations and stuff back to 0, because this is going to be used for tweaking and adjusting any stereo that we need to later. All right, sweet. And let's just go ahead and label this properly as the left eye. Axis left. All right. And we're going to just simply copy, paste this entire thing over here. There we go. And let's connect that data over there. It's going to get a little messy. So now we have a left eye and a right eye. And one thing that I find will be very helpful is if we go ahead and put a join view node after these two. And that way it basically color codes whatever we happen to be looking at as the red and green. And let's go up here and call this one right. Now we already have our stereo cameras and they're right over here. So let's take these guys and make a copy of these. And we'll bring them up here. So we have our stereo cameras already, and all we need to do is we need to connect the axis to the stereo camera. And that should place us directly into the cart. And do the same with the right eye as well. Awesome. So now where our cameras are actually in the cart, but they're facing the wrong direction. Now, why are they facing the wrong direction? Well, it all has to do with how it's being filtered through all this whole system and what images are getting stitched together. It's a 360 camera. So technically, this isn't actually rendering backwards because the screen is right there. We can just turn our head around. But because of the way an equatorial panorama works, we generally get more pixel density in the center of the screen than at the bottoms and the tops. The bottoms and tops get squished quite a bit because they're basically taking all of these pixels and putting them into a very small area directly below and directly above. So you want to have the screen running through the middle, but it also, because of the way this is bowed out, and I don't want the main event is the screen, right? And I don't want it running down the image seam. So what we're going to do here is we're just going to come down to the circle transform. And we can actually rotate it right here. We can say RY. We can actually rotate it 180 degrees. So the screen is now in the center of the screen and we're pointed the correct direction. And if we go to frame like 260, where we're the closest to the movie screen and the troll's swiping at us and reaching out at us, right? That's where this is going to be the most resolution for him. And hopefully it's not too bad, because we did originally make this at 2K. Now it's basically going to be rendered at 1152 by 680. So we're kind of going half res, but we have the limitation of this size for our playback. So in the end, well, it is what it is. And hopefully in the future we can do more high res imagery, because it really needs to be something like 12 by 6K to get really good definition in all directions on one of these. So we made a change to that one, so we have to make sure that we don't forget to put the 180 on the other eye as well. All right? Now, our position inside, our 360-degree camera position inside the ride vehicle is a little high and a little bit in the middle of the vehicle. And that's because that's where we were rendering for creating the screen. But for this experience, I want to move down into the front row and possibly into one of the seats. So that's where our little positions right here on the axis left and axis right node really do help us switch that up. So I'm going to go ahead and do a view of the 3D scene. And we're going to go into where our camera is so we can see where it is on the ride vehicle. All right, it's right there. Okay, I'm going to zoom out, click off. There we go. And we can see where it is, right? You can see that it's in the center of the ride vehicle. We want to bring it out and down a little bit. So we're going to take our axis left, and we're going to probably, see, maybe 2.8, bring it out and down a little bit like that. All right. So that way it's down in the front row. And we're also going to have to do the exact same thing to this other side. So let's do negative 2.8, negative 1.9. There we go. So you can see there's the original stereo cams. They're still there. But we've now moved our 360 cameras down to the seats here. And if you wanted to render it from the point of view of this seat or that seat or wherever, you could literally just drag it over and move it and figure out what the value would be, like 8, and then do the same thing to the other node. Move it over by 8. There you go. And now you see that would basically be the head of somebody seeing this in stereo. So now let's go back to our 2D and see what that's going to look like. And there we go. So you can see now that we're sitting on the last chair on the right-hand side. We've got our safety bar right there. There's the front of the ride vehicle. We've got our experience happening. And you can see the chair that we're sitting in is split between the left and the right. And there's the 1, 2, 3 other chairs over there. So you can see where we're going with this. I'm just going to put it in the middle of the ride vehicle. But that's what's happening. So I'm going to put this back to there. I want it to be in the front row, but I still want it to be somewhat center view. And that's okay. But you can move it to a different location if you want to. The other thing to think about is once we get these views down here, we want to look at it in 3D. And when I started looking at this in 3D to see it actually in stereo, the 3D for the environment looks great. It feels really dimensional and really good, but the 3D inside the ride vehicle, because it's so close to your face, is really difficult to resolve. And you can see the disparity between the two eyes right here is very pronounced. Now, inside of like a more dynamic environment, such as an Oculus, it does all kind of a real-time convergence adjustment when you're dealing with real time. But since we're baking this out, and we just have to be aware of this and make things a little bit easier to look at. So on the axis node, I'm going to put in a value of 0.5, and on the right eye, a value of negative 0.5. So that way, it brings the two eyes a little bit closer together and eases the stereo separation a little bit, and it still has a good 3D depth, but the disparity between the two eyes on these parts, which is going to be really stressful, is going to be much, much better. But it does diminish the 3D effect on some of the environmental effects, but it's still there and it still looks good. But this tends to be a much better setting for our particular shot. I'm popping on anaglyph glasses just to verify it all looks okay. All right. Now, the only other thing that I want to do before I set this up to render is adjust certain render settings, because some things like the grass right here are really jaggedy. And that's happening because what we're getting is out of a scanline render, well, we have no anti-aliasing. So you can switch it to high and it will look a lot better because it will anti-alias it. But the render penalty is astronomical. I've been using medium and switching my filter to notch to get a little bit better fidelity in that. Now you can see right here where the front view and the next right-hand view, the difference between these blades of grasses and this over here. So go ahead and play with these settings, see what you can do. This is the setting that I've gone with. It's pretty heavy. The render times that we're looking at for this in stereo with all of this happening, what I got on my 8-core 4.2 gigahertz per core machine was around 12 and a half hours on one machine. So if you have access to a render farm, awesome. But it will render in about 2 hours without any anti-aliasing. It is a very heavy render. We're doing some pretty heavy lifting on this. So we've got our join view right here. And the only other thing I want to do is I want to make sure that the that lighting pass that we did for the end of this, when we go in the tunnel, how it gets darker, that trick is still over here. So I'm going to come over here and I'm going to copy this. And we're going to paste it into here as well. Now you may be wondering, will this work? Well, what's really cool is that through all these scanline renders, they're outputting depth. And the spherical transform also outputs depth. So if we switch this to the depth channel, you can actually see that there is full-on depth available for us. So just literally copying this over and just plugging it in, it will work. It'll work the exact same way. We can tweak it, but we don't need to. It will work as is. So I'm just going to copy this up there, put it together, and that should darken down the tunnel area right there. Of course, I need to view it. There we go. So you can see what's funny is I can see that it's also darkening down the movie screen in the back. That was a unexpected result. But that's okay because we're supposed to be facing forward and you probably won't see that. But I might clean that up for next week. All right, so last thing is let's just set up a write node. And we're going to set this out to our composite class9 comp. And we will set this out to our final lat long. This will be in stereo, so we need a %v dot %04d dot png and give it a render. Now, this render will take a very long time, as I was saying. I'm going to pull up my render. All right, so here's what the final render is going to look like. And we can see that, it's working out pretty well. So go through the process and set this up and do whatever tweaks you want to do. We have to have this all rendered out by next week's class. We're going to go ahead and go through the process of compiling this into a QuickTime movie. We're going to get it online. We're going to use some of the products like the Android phones and Oculus to see this and experience it in VR and talk about what it takes to get it online and out there. So if you have any questions, hit me up in the forums. And until next week, I shall see you next time. And thank you so much.